Hi, everyone. I'm Ellie. I'm a postdoc with SEAS, and I also work with the Sapiens Centre of Human Behaviour and in the Earth Sciences Department. And today I'm going to be talking to you about whether we can tell if a shell has or hasn't been heated by an early human. So humans have relied on the ocean for a very long time. Our ancestors, hunter-gatherers, have foraged for shellfish and they've speared fish. And yet, despite this long relationship, we still know relatively little about what early humans were actually doing with the shells that they were gathering. So, for example, we know that a shellfish doesn't naturally live in a cave. And so when we see them in the cave sites in South Africa, as highlighted on the map here, it kind of gives us an indication of early human behavior, and also that humans were deliberately taking them to the cave. It tells us something about whether or not the early humans were cooking shellfish, whether they were eating shellfish, and it could also indicate discard and garbage strategies from early humans. And also more broadly, it tells us about human behavior in terms of their thinking, their fire use, and also their daily activities. And so before we actually can use a shell for any type of analysis, we first want to know whether it's been heated. And this may seem really simple, but it's really important both for understanding early human behavior, but also for other types of analyses. So we often use oxygen isotopes for past sea surface temperature reconstructions, and yet we can't actually use a heated shell for this, as heating changes the internal shell chemistry. So we first, before doing any sort of climate reconstruction, need to identify if the shell has been heated. And so to explore this, I've been using modern opercula, which are the round lids that go into the opening of a marine snail shell, to do this. And they come from the species Turbosomaticus, which are present in South Africa along the coastline, but we also see a lot of them in the archaeological sites in South Africa. And so that already suggests that humans were using them in some way. And to kind of reenact what early humans were doing, we heat these shells to different temperatures in the lab, and then we perform analysis on their structure and also their chemistry. And the first set of results that I'm showing is to do with color change. So as we increase the temperature of the shells that have been heated, we see a color change. And we specifically see this color change from about 350 degrees to 450. We see that they darken, but we also notice that there are more thermal cracks occurring at these temperatures, at these higher temperatures, suggesting that there's a structural breakdown in the shell material as it responds to heat. And so we wanted to explore these cracks in more detail as well. And so we use a scanning electron microscope to hone in on the cracks to see whether we can see this under the microscope. We can, which is great. And we see that even at relatively low temperatures, there are more cracks forming. And this suggests that the stress actually begins a lot earlier than what we see in the thin section, so in color, for example. And so our next step is to compare this with what we see in the archaeological record, to compare the patterns that we're seeing in the modern day shells to the archaeological ones, to see whether they've maybe been heated as well. And finally, we also measure clumped isotopes in both heated opercula and also in heated modern bivalves from South Africa. And when we compare the temperature that we heated the shells to along the x-axis with the reconstructed clumped isotope temperature along the y-axis, we find a linear relationship and a sort of calibration curve. And so this means that we can now take a heated or a potentially heated archaeological shell based on our previous observations. We can measure the clumped isotopes, and then we can effectively read off with our calibration curve the actual temperature that a shell was heated to from our past sites. So we can get an understanding of the temperatures that early humans were potentially heating the archaeological shells to. And from that, we can begin to infer how ancient people might have used fire, whether they were cooking with the shells or discarding of their waste in a certain area, maybe near to a fire. And ultimately, this approach helps us to connect the geochemistry of a shell to the everyday behavior of early humans, so our ancestors. Thank you very much for your time.